All right, this is Mrs. Carreri's solutions video for practice test from Unit 1. It was part 2 of this unit because we split this unit up into 2 parts. So you should be able to see that here. And sorry about that. Okay, so here we go. Basically, the first one is providing the 5 variables for the UAM equation. So we have displacement, symbol is delta x, units are meters. Velocity, initial, symbol is VI, units is meters per second. Velocity, final, V sub F, meters per second. Acceleration, A is the symbol, meters per second squared. The last one is time. T is what we use for our symbol. S is the unit. The velocity of an object measured over time is graphed in figure 1. Excuse me. Okay, is graphed in figure 1. Refer to figure 1 for the questions. Number 1, calculate the acceleration during segment A. So here's segment A. They want to know the acceleration. By definition, acceleration is change in velocity over change in time. The other thing is the slope of a velocity versus time curve is meters per second over second, which is meters per second squared. So I can find the slope of that line of A, or I can calculate delta V over delta T with related to A, which by the way, will give me the exact same equation. So here's my point. Slope is Y2 minus Y1. Y2 would be 10 minus 0 over X2, which is 5 to minus 0. 10 over 5 equals 2 meters per second squared. Velocity initial is 10. Velocity final is 0. Time initial is 5. Time final is 0. So V final minus V initial over T final minus T initial. This equation right here is on your yellow sheet. Which segment, if any, its acceleration is 0? Explain. B, Y, slope is 0. Or the change in velocity equals 0. During segment B, the velocity is 10 meters per second the entire time. Number 3 is a free-fall problem. We have a situation where a person is at Hume Lake. They have a rock in their hand off a cliff. They drop the rock. They let the rock fall below. The time it takes to hit the ground is 1.9 seconds. If it was dropped and released from rest, we know the initial velocity is 0. This object is in free fall and the acceleration is downward. We will assume standard coordinates. So this should have been Y. This is negative 9.8. This is 0. This is 1.9. So the question is, what is the velocity just before it hits the ground? V final equals question mark. So we can solve using UAM equations. V final equals V initial plus A times time. I know initial velocity, I know acceleration, and I know time. 0 plus negative 9.8 times time, which was 1.9 seconds. And that will give me a value of negative 18.62 meters per second. I'll use 3 sig figs, so there we go. There is A. B, how high is the cliff? How high is this height right here, height? I'm going to find delta y. Delta y equals velocity initial times time plus 1/2 A in the y direction times t squared. Initial velocity is 0, so velocity initial is 1/2 times negative 9, change in position is 1/2 times negative 9.8 times the time squared. So delta y will be a value of negative 17.7 meters. That is not the answer to the question. The height is a positive number. It's 17.7 meters. That is the answer to the question. Delta y, which is change in position, displacement, was in the negative direction. That's why it comes out negative, but height's a positive number. 2, baseball player decides to throw a ball up in the air. Just throws it straight up. The ball leaves his hand with a positive velocity upwards. This ball is in free fall, so while it's on its way up, acceleration is downward of 9.8. So this is negative 9.8 meters per second squared. It's always negative, it's always down because the ball is in free fall. Now at the very top, we know the velocity is equal to 0. And what they asking for, oh, they determined that this height, which will be delta y, was 8.2 meters. So 8.2 meters, that's delta y. Initial velocity, I don't know, but I want to find it. The final velocity at the top, the max height velocity is 0. So that's the key feature there. I've got 3 things, so I can solve for the initial. How am I going to find it? I have to use this equation. You got to find an equation that has values that you can solve for. I don't have time, so I have to use one that doesn't have time in it. I need to move everything around and solve for V initial. V initial squared equals V final squared minus 2a delta y. I've got to take the square root of both sides. That'll be plus or minus. V initial equals the square root of minus 2 times negative 9.8 times positive 8.2. So negative 2 times negative 9.8, that's a positive number, which is good because I'm not taking square roots of negative numbers. And that will give me velocity initial equals. Now you have to ask yourself, is it the positive value or the negative value? What's on its way up, velocity initial, so it will be a positive number, and that'll be 12.7 meters per second. Here's the last problem, hardest problem on the test, at least in my opinion. So we got to take and find all the things. Well, the plane is traveling horizontally. Here's the horizontal velocity. That is the velocity initial in the x direction. It is 40 meters per second. Initially, the velocity in the y direction is 0. There is no velocity in the y direction initially. Now in the y direction, this has a value of negative 9.8 meters per second squared for the acceleration because it is in free fall. The object's in free fall. The velocity in the x direction will never change because acceleration in the x direction is 0. There is no forces in the x direction. Velocity in the x equals 40. This equals 40. At all times, this equals 40. Now, the velocity initially in the y is 0, but then it starts to get a little bit bigger and then a little bit bigger and a little bit bigger because it's accelerating downward. So there will be a final velocity in the y direction. I don't know what it is. So let's go see what information we have. Do we know the change? Again, we'll use standard coordinates. So up is positive, to the right is positive. Do we know the change in position? Well, we'll call this y initial. We'll call this y final. And y final is downward by negative 100 meters. Okay, so it went in a displacement of 100 meters in the downward direction. You called down negative. The initial velocity in the y direction is 0. The final velocity in the y direction, I don't know. The acceleration in the y direction is negative 9.8 meters per second squared. So I've got 3 things. So I can solve for my variables here. Now, acceleration in the x direction is 0. These 2 numbers will always be the same. There's only one equation in the x direction that really helps us, and there's only 3 variables. And I only know one of them. I only know that it's traveling at 40 meters. Oops, wrong location. 40 meters per second in the x direction, which, by the way, is never going to change because the acceleration is 0. So in order to solve for anything in the x direction, I have to have either two of the three variables. Here are the three variables, delta x, and velocity in the x direction, or time. So let's see what we have. So A, what is the horizontal velocity of the package? Horizontal, so that's in the x direction, just before it hits the ground. Vx final equals question mark. Well, since there is no acceleration in the x direction, Vx final equals Vx initial, which equals 40 meters per second. In the x direction, it never changes. Just because I'm accelerating downward in the y does not mean I'm going to impact anything in the x direction, because they are independent to one another. What is the vertical? So now they're asking for vertical velocity. Vertical is in the y direction, just before it hits the ground. What is the final velocity in the y direction? That is vertical. Well, I have three things here in the vertical direction, and 5, 4, 3, 2, 1 rhymes states if I have a total of 5 variables. If I know 3 of them, I can find the other 2. I do have 3. So I don't have time, so I have to use an equation without time. Final velocity in the y direction squared equals the initial velocity in the y direction squared plus 2 times a in the y direction times delta y. Well, this is 0, and that will equal 2 times negative 9.8 times negative 100 meters. And then I have to take the square root to get rid of the square. And I will find, again, don't forget that's plus or minus, that velocity, gotta find my answer, is equal to 44.2 meters per second. And since I'm smart enough to realize that it's plus or minus, and this is moving downward, when I hit the ground, that's negative 44.2 meters per second. C, how long does it take to hit the ground? Once again, I don't have anything in the x direction except 40 meters per second, so I can't use data from the x direction to solve that. And so C, I will find time by using the equations in the y, which are all of the UAM equations, and I have to find time. And I'll use the easiest equation, which is the first one, velocity y final velocity initial in the y plus a times t. T equals v final y minus v initial y over a. Now I'll plug in numbers. Negative 44.2 minus 0 over negative 9.8. And time equals positive 4.51 seconds. Good thing it comes out positive. It would not be correct somewhere. I'd do something wrong if it came out negative, because time is positive. That is C. D, where does the package strike the ground relative to the point at which it was released? What are they asking for? They're asking for delta x. Delta x. So delta x equals question mark. I only have one equation for delta x, and there it is. Delta x equals the velocity in the x direction. You can call it initial, you can call it final. It's the same velocity the entire time, times time. Well, I just found the amount of time that it took to hit the ground in the y direction, and time is a scalar. So this is 4.51, and that can go now over to the x direction and use it because it's scalar. It has no direction. Time can go back and forth between dimensions. So delta x is equal to 40 meters per second times the time I just found in the previous problem. And that will give me a value of 180.4 meters. So there's the answer to D. One more question, and it is the hardest one that I feel like students ask. E says, what is the final velocity? I didn't ask for the final velocity in the x direction. I didn't ask for the final velocity in the y direction. Here's the final velocity in the x. Here's the final velocity in the y. But the actual velocity vector looks something like this. So we have to take that x and y vector. We'll draw one here that's 40. It's to the right. The y vector is downward at 44.2. And the resultant vector of those two will be the final velocity. I will use the Pythagorean theorem to find v final. So we know that V final squared is equal to 40 squared plus 44.2 squared. We will find V final to be equal to, add them up, square them, take the square root, and that will be 59.6 meters per second. Okay, now I'm not going to put a negative or a positive there because I'm actually traveling in both the y and the x direction. It's a vector. And so I've an answer of 59.6 meters per second is not 100% accurate. It's only you've only given the answer to the velocity of the magnitude. Every vector has a magnitude and a direction. When we gave the velocity final in the y direction, we said 44.2 meters per second, but we said downward. Okay, so we need the angle in this case because we are not in the positive or negative, we're in both. So I got to find theta. And so I'm going to say that tangent theta is equal to the opposite. Tangent is TOA. So opposite side is 44.2. The adjacent side is 40. And so what do I need to do now? I have to I got to get theta all by itself. I need to take the inverse tangent of the right-hand side, I'm sorry, the left-hand side, to undo the tangent, and then I will take the inverse tangent of the right-hand side. So essentially, we get theta equals the inverse tangent of 44.2 over 40. And theta will be equal to 47.9 degrees. So the answer is 59.61 meters per second at 47.9 degrees below the horizontal. That is the answer to E. Hope that helps you in studying for your Unit 1, Part 2 exam.